Okay, here we go. Beginning chapter 12. We'll have a chapter test next Friday, and then we'll move into the semester final. More about that as we get closer. Homework tonight. Okay. Chapter 11 was all about area, and chapter 12 is all about volume and the surface of a three-dimensional shape. We're going to calculate the area of that, so that's going to be surface area. So surface area, we deal with this chapter. Surface area is a two-dimensional shape, even though it comes from a three-dimension. Think about just the outside of a shape laid flat on a surface. That's why it's called surface area. It's an area, so it's measured in square units. Take a box, lay the box flat, just the surface of it, calculate the area of that. That's your surface area. And then secondly, we'll be calculating volume. Volume is of the three-dimensional shape itself. And volume will be measured in cubic units. In other words, how many tiny little cubes can you fit inside the shape? It's good news, bad news. Good news, it's just formulas and you plug numbers in. The bad news is there's lots of them. All right. So good news, it is plug and chug, but there's lots of them. So here we go. Take a bunch of polygons. We're going to get our first definition here. Take a bunch of polygons. Got to be polygons. Join them together on their edges. Can't join them in the middle. Got to join them on their edges, and you make shapes, three-dimensional shapes. And we call these shapes. We call these polyhedrons. Poly for many. These are three-dimensional shapes made up of polygons, and it should say join at their edges, but well, I just said it, so there you go. I remember you can always hit the pause, but I'm moving on. All right, the first type of polyhedron we will study is take two polygons that are congruent, place them parallel to each other, and then join the sides with parallelograms, and you make something called a prism. A prism is a polyhedron consisting of two congruent polygonal bases connected with parallelograms. Okay, so we're going to label pieces, parts of prism. Put it on pause, take a moment, draw that prism down there, and then we'll label all the parts. Okay, so the first part is the bases. The bases are those two congruent polygons. They could be any polygon. They got to be the same polygon, though. Triangle and triangle, rectangle and rectangle. In this case, hexagon and a hexagon. Also make sure they're parallel to each other. All right, the sides, right, that join the two polygonal bases are parallelograms. And since they're on the side, we call them lateral, and some genius decided to call them faces, so we call them lateral faces. And it kind of makes sense. The face is what immediately is in your direction. In other words, it faces you. Where the faces come together, they come together at an edge. It's marked there in red right there, and we call those lateral edges. And one thing to notice is that all those lateral edges are parallel to each other. Lastly, if we measure the distance between the two bases, we call that, well, technically it should be called a height. We also like to use the word altitude. So altitude and height are used interchangeably. And remember, it's always measured perpendicularly, and that's the distance between the two bases. Okay. There's some more parts, but we're going to say that all prisms come in two main flavors. The first flavor is there in front of you, and that's where the lateral edge and the base form a right angle, and therefore we call this a right prism. The second main flavor is, well, what if they're not connected at right angles to each other? In other words, the bases are moved away from it. They're not directly above each other. So if we move them sideways like that, here's a pentagonal prism. If we move them sideways, well, it's not a right prism anymore. We call this one an oblique prism. And by definition, it simply says that the sides are not rectangles, they're parallelograms. On a right prism, all the sides will be rectangles. How do you measure the height of an oblique prism, especially if those two bases are far away from each other? Well, you measure it off to the side. This particular one I drew, you could measure from the center of the bottom to it wouldn't go to the center of the top, but you could still draw a dotted line to the top. And that's called the altitude. So this entire chapter, we're going to be doing two main things. I'm going to give you a three-dimensional shape. You're going to be calculating the surface area of it, and you'll be calculating the volume of it. So we're going to hit formulas for both. All right, so the first big idea is the surface area. Our book doesn't call it surface area. It calls it total area. It's the same idea, though. All right, so let's see. To calculate the surface area of that particular prism, we would have to calculate the base area. Our book uses a capital letter B to represent the area of the bases. And I should say the area of one of the bases. So since prisms have two bases, then the area of the base of the prism is actually equal to 2B, 2 times the base area, because we got two of them. The sides, think this one through. The sides, since it's going to be a right prism, we're going to call the lateral area. And so we abbreviate lateral area LA. That's just the sides. So what would happen if I took the lateral area and added 2B? Well, you would get the surface area, except they don't call that surface area. Our book calls it total area, total area. Now, you can remember it as either surface area or total area. That's fine. But for the book, when you're doing your homework, they're going to ask you for total area. And that would be the lateral area plus 2B, because remember, there's two bases. And it's a capital B, total area. All right, so that is our first formula, and that's for surface area of prism. We'll write it down officially here in just a second. Let's just investigate where those two pieces come from. So quick proof. Let's think about the lateral area of just a right prism. So the sides are rectangles. So there's a triangular prism right there. And if I were to cut out the top and the bottom, oh wait, I wouldn't be able to see the back, so I'll put some dotted lines there. Well, if you can notice, then that shape is made of nothing, if I laid it flat, nothing but rectangles. And we can calculate the area of rectangles. That's just base times height. So let's see where the base of our shape comes from. Well, the base would be that right there that I'm blinking red. And that, where would that be on the prism? Well, that would be hey, that's the perimeter of that triangle. So we could say the perimeter of the base of the prism times the height of the rectangle, and the height of the rectangle would be the height of the prism, or its altitude. Well, that would give me the lateral area. And that was actually a proof. That's our first formula. So this is theorem 12.1, which simply states the lateral area of a right, it's got to be right prism is equal to pH, where P is the perimeter of one of the bases. The bases are congruent, so either one. And height is the altitude of the prism itself. All right, so that one wasn't too bad. What the book leaves off, but what homework will ask is, what is the total area? So the book doesn't give us a total area formula. It does give her a base formula. It does give the lateral area formula. It expects you to put those two things together. So let's just put those two things together. So if I want to do the total area of that shape right there, I would have to take the lateral area and add 2B's to it. So this is not in the book. Like, they don't even mention this. They just expect you to figure this out yourself. All right, so put this somewhere in your book of truth. So total area for a right prism is pH plus 2B. I'm like, didn't I just write down LA plus 2B? Yeah, but we can refine the LA to P times H, where P is the perimeter of either one of the bases, and height is the altitude of the prism. Okay. And remember, we're multiplying by 2 because there's two congruent bases. That's the total area. All right, so for the fifth time, total area and surface area are exactly the same thing. Now, you will not be given nice, easy, friendly, 7th and 8th grade versions of this. You're going to be given a challenging one. So here's a challenging one. It says, calculate the total area of the right prism. So it's telling us it's a right prism. Prisms are named after their base shape, and the base here is a trapezoid. So this would be a trapezoidal prism. And we got a formula for total area is pH plus 2B. So I need to get the perimeter of the base. Well, the perimeter is a trapezoid. So if I mean, hey, all those dimensions there are labeled. I'm just looking at the trapezoid at the top. That'd be 12 plus 5 plus 6 plus 5, not the 4. The 4 is the height of the trapezoid. So 12 plus 5 plus 6 plus 5, that would be 28. And then the height of the prism itself is 10, not the 4. The 4 is the height of the trapezoid. So what do you use that 4 for? Well, when we calculate one of the base areas, the base in this particular case is a trapezoid. So we reach way back to one chapter ago to the trapezoid formula. There it is right there. We need the height of the trapezoid, which is 4. We need the two bases. Those are the two parallel sides, which is 12 and 6, and divided by 2. 6 plus 12 is 18. 18 divided by 2 is 9, and 9 times 4 is 36. So remember, that's just one of the bases, and we have to multiply that by 2. So let's put it all together. That would be what? 280 plus 72, and that would be 352. Now, what we do in volume or surface area? We're doing total area / surface area, and that would be measured in square units. So square centimeters in this case. Hopefully that made sense. Rewind the video, play that again. It's the same procedure for all the right prisms to calculate the total area surface area. All right, second big idea, remember, is volume. Let's think this through. If I have a large box and I want to measure the volume, well, I construct a smaller box where its dimensions are 1 by 1 by 1. Well, what units? Any units you want. Centimeters, inches, miles. You just need a box that's 1 by 1 by 1. Fill the larger box with those smaller boxes and then count how many smaller boxes you have. That would be the volume of the shape. So the volume is the amount of space in a three-dimensional object, and it's measured in cubic. That's 1 cube right there. How many cubes you have, count them all up. It's measured in cubic units. Okay? So for right prisms right here, we got a right prism because it says so. The volume is the base area, and if you can imagine that triangle there, that green one, right? If you were to stack green triangles of the same size, one on top of each other, well, that would cover the entire shape. Well, how many green triangles you have? Well, that would be the altitude. So capital B, remember, means base area times the height of the prism itself, and that would be your volume. So it turns out, and this is almost true for all the shapes, that the volume formula is always a little bit easier. So this is theorem 12.2 that says the volume of a right prism is capital B times H. Okay, so our same shape right here, let's calculate the volume. Excuse me. All right, so let's see. We're supposed to use the formula of capital BH. H is the height of the prism. The height of the prism is 10. Capital B is the area of one of the bases. We did that in the previous calculation. Remember that? Let's see. The height of the trapezoid was 4. The two bases were 6 and 12. I think we got 36 if I remember right. And the height of the prism is 10. Well, that's a pretty easy calculation, 360 cubic centimeters. All right, there's a couple more challenging ones, and these will be ones where you're not given all the dimensions you need. So notice here, we actually have an extra dimension right here. It tells us what the volume is, and it says calculate the total area. Let's see, what total area formula is, we need the perimeter. Hey, I got the perimeter of the base. 7 plus 6.5 plus 10.5. That'll be what, 24? The height of the prism is oh, crud, it's H, and I don't have H listed. So in order to do my calculation for total area, I need to find the height of the prism. I can do the rest of it pretty easy. I can also do base area right here. The base is a triangle. Formula for every triangle from last chapter is base times height divided by 2. Base is 10.5. Height of the triangle, not the prism. The height of the prism is 4, right? 4 times 10.5 divided by 2 is 21. That'll be 42 divided by 2. So the only thing I really need to do is find that height, and I'm done. How in the world am I going to find the height? Well, let's see. Any other information we have there? Oh, yeah. Volume is 315 cubic units. Well, volume is calculated by capital BH. I just calculated the base area. The base area was 21. Well, there I have an algebra formula equation right there that I can solve for H. Divide both sides by 21, and it turns out that the height is 15. Therefore, I can toss that 15 into my formula, and away I go. Quick calculation right there, that would be 402. And we're doing total area, so don't mix it up with cubic units. So square unit. Notice there's no units there. All right, so that was a slightly more challenging, but you can, if you take your time, you can logic your way through that particular problem. All right. Boy, does this chapter like to use tables, right? Let me get to the tables. will include the abbreviations TA, total area, V for volume, little b for base, capital B for base area, and an H for altitude. So just use those abbreviations to do your calculations. And a few of them, I'll go back to this slide. A few of them might require you to do a little bit of algebra in order to get to the answer. Like it won't give you all the information you need. It might give you volume and ask for height like we did right here. All right, so hopefully that made sense. If you run into problems, send me an email. You're doing good. I will have your, I'm doing this early in the morning before I go to work. I will have your test graded probably this evening sometime. This is a Friday when I'm doing this. So yeah, that'll be it for today. Have a good weekend, and I'll see you on Monday.